This unit, or this lesson, I mean, is lesson 6.5, which is all about geometric sequences. Now, you may remember back from first semester, we did something called arithmetic sequences. All right, I think that was around unit 3 last semester. Very similar, but slightly different. So with arithmetic sequences, arithmetic typically deals with you're adding and subtracting a number to get to the next number in the sequence. Geometric, you're typically going to be multiplying or dividing a number to get to the next. Now, arithmetic, we could write rules for it in forms of linear equations. So if you guess this whole unit's on exponential, geometric, we can write exponential functions to represent those sequences. All right. So go ahead and take out that journal, and we'll just go ahead and get started. So your I can statement for this lesson is I can determine if a given sequence is geometric and identify the common ratio and write explicit and recursive equation for it. So, some of those words you may seem familiar to you, all right? So, the words that should be familiar to you are common ratio, because we already talked about that within this unit. When I say common ratio, what do I typically refer to in terms of an exponential function? What's another name for the common ratio? Not the y-intercept, but you're kind of in. So think about exponential functions. So this form, y equals ax plus b, or Lord, y equals a times b to the x power. Which of these values typically gives you the common ratio? B. Remember, B, the B value, the name for that, or the official mathematical name for that, is the common ratio. And remember, the B value is what we were typically multiplying between our Y values of our table to get to the next value. Now, explicit and recursive equations, they may be kind of tingling in the back of your mind, like you've heard it before, but you just don't remember what it is. You use that back with arithmetic sequences. So just to review an arithmetic sequence, so you may want to write this off to the side. So with arithmetic, you were typically given two types of formulas. You were given the recursive, which was when you had a of 1 equal to k or some number. So k is equal to some number. Yes, ma'am. And then a of n is equal to d plus a of n minus 1. All right, so that's the recursive formula for arithmetic sequence. Then you had the explicit, which was simply a of n is equal to a of 1 plus d times n minus 1. And again, this is just to kind of review. You already learned this last semester around unit 3, I believe. Now, does anyone remember what a of 1 means in terms of a sequence? You're on the right track. So keyword first. First what? It's the first term. Good. So A of 1 represents your first term. So whatever number is stated first in the sequence is your A of 1 value. Does anyone remember what D meant? Caleb, you want to get some water? Go ahead. Yeah, go ahead. Does anyone remember what D means? I'll give you a hint. Mathematicians are not they're very blunt when it comes to labeling things. So think of a word that starts with the letter D.
Diameter.
Think about it. Arithmetic means you're adding and subtracting a number. Not decrease, but you're on the right track. So adding or subtracting a number. What's another name that starts with the letter D for one of those operations? Is it? Not dividing. What's another name for subtraction that starts with a D? Decreasing, not quite. DIF. Difference. So your D value stands for common difference. All right. So basically, it's the number you're adding or subtracting. So in other words, it's the number you add or subtract to get to the next. Now, that's an arithmetic sequence. That's just a very quick review of arithmetic. So remember, with arithmetic, you are adding or subtracting a number to get to the next. Geometric is different. So with a geometric sequence, it's a discrete exponential function. And all discrete means is that they're counting numbers. So if we were to graph it, it'd just be a bunch of points. All right? That's all discrete means. Now, the terms in the list increase and decrease by a common multiplier. And that common multiplier is called the common ratio, or your R value. All right? So, like I said, when you're thinking y equals a times b to the x power, this is known as your common ratio. But in terms of geometric sequences, we're going to call our b value r. Now, with geometric, another thing to note, geometric sequences, you are either going to be multiplying or dividing a number to get from one number to the next. So arithmetic's adding, subtracting, geometric's multiplying, dividing. And the reason I'm telling you this is because this next example is asking us to determine if a sequence is arithmetic or geometric. And then it wants us to identify A of 1 and either its D value or its R value. So remember, A of 1 is just the first term. D is the common difference. And remember, that's used with arithmetic sequences only. And your R value is common ratio. Shh. And remember, that's used with geometric only. So every example is going to have an A of 1 value, but the D and R value depends on what type of sequence it is. So if it's arithmetic, it's going to have a D value. If it's geometric, it's going to have an R value. You're never going to have both. So look at example A. Take a minute and see if you can figure out the rule. So you're either going to be adding a number to get to the next, or you'll be multiplying a number to get to the next. So take a minute, see if you can figure out the rule. So guys, laptops should be put up. I should not see them out. So just example A, take a minute, see if you can figure out the rule. So whether we're adding something, multiplying something, subtracting something, dividing something. And remember, it needs to work between each number. All right. Raise your hand if you got it. Okay, let's go. Chris, what you got? We're adding 4 between all of them. So we're going to add 4. 8 plus 4 is 12. 12 plus 4 is 16. 16 plus 4 is 20. So if we're adding a number, is this going to be arithmetic or geometric? It's arithmetic because we're adding a number. Now, what's my A1 value? So what's my first term? 4. Now, since it's arithmetic, am I going to have a D value or an R value? It's D. And what's my D value? So what am I adding to get to every number? 4. So your D value, remember, is whatever number you're adding or subtracting to get to the next number. All right, so that's letter A. Take a minute, see if you can figure out the rule for letter B. So you're either adding or subtracting or multiplying and dividing a number. Oh, God.
Subtract, multiply, dividing. Check it out.
Back and Siri can pick up my voice only.
All right, raise your hand if you got the rule. All right, let's go, Aiden. What you got? Right, we're multiplying by 2 to get to each number. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 4. So, since we're multiplying a number, would this be geometric or arithmetic? Geometric. All right. So, what's my first term? 4. Now, would this have a D value or an R value if it's geometric? R. So remember, your R value is the number that you're multiplying to get to the next. So what's my R value? 2. So again, arithmetic, you're adding a number to get to the next. Geometric, you're multiplying a number to get to the next. All right, look at letter C. So I'll give you a hint with C because it's decreasing, yes. Oh, wait just a second. So with C, think about, you may have to divide or subtract, but then think about what number you'd actually be adding or multiplying to cause that operation. All right, who's got the rule? Elise. We're dividing by 2. So if we're dividing by 2, what number are we technically multiplying by? So think about it. 36 divided by 2 is 18. What number could we also multiply by multiply 236 to get 18? So a number we can multiply to 36 to get 18. 1/2. So remember, if you divide by 2, that's the exact same thing. So dividing by 2 is the exact same thing as multiplying by 1/2. And that works for just about any number. If you divide by 5, it's the same thing as multiplying by 1/5. Divide by 3, multiplying by 1/3. All right? So we're technically multiplying by 1/2. Now, the reason we're multiplying instead of dividing in this case, like, yes, you can say it's divide by 2, but when we actually get into writing the rules, you got to know the number that you're multiplying. All right? It's similar to when we were doing exponential functions and we're trying to figure out what the b value was, how we always had to figure out what the number we were multiplying to was, because that was our b value. So we're multiplying, so it's geometric. Your a value is 36. What's your r value? For a of 1, I should say. What's your r value? 1/2. All right, last one. Think about this carefully. What do you think the rule is for the letter D? Gary? Adding 1.25. Now, when you're dealing with decimals, it can get a little dicey. What's a good strategy that you can use if it's kind of hard to see what the rule is? How can you test to see what the rule is? I'll give you a hint. It involves your calculator. What's the easiest way to figure out a rule between numbers?
Divide the last number of the sequence to the beginning.
Right. So we can either divide the last number by the beginning number, or we can, if we're trying to do arithmetic, we can subtract the beginning number from our next number. So for example, I could do 2.5 minus 1.25, and it'll give me 1.25. Then if I did 3.75 minus 1.25, still gives me 2.5. So we know our rule stands. All right. Now, let's say I wanted to check to see if it was geometric. I could do 2.5 divided by 1.25, which is 2. Now, we should get the exact same answer when I divide 3.75 divided by 2.5. It's not. So because it's not, it can't be geometric. But since 3.75 minus 2.5 is still 1.25, and 2.5 minus 1.25 is 1.25, we're supposedly adding 1.25. So it's arithmetic, because we're adding or subtracting. Your a of 1 is 1.25, and your d value is also 1.25, because that's what we're adding or subtracting. So guys, that's just a strategy that you can use to check yourself in your calculator if you can't just look at it and tell what the rule is, because sometimes it is hard. Any questions on identifying whether it's geometric or arithmetic? All right. Now let's look at how to actually write the formulas for geometric sequences. So remember, y equals a times b to the x power is an exponential function in its prime form. So we've been using that all through this entire unit. All right, so pretty much all last week, that's what we dealt with exclusively. All right. Now, b is still your multiplier or your common ratio. So that's why I said another name for b is your common ratio. Now, just like how arithmetic has a recursive and explicit formula, geometric also has a recursive and explicit formula to describe what's going on in the sequence. They're actually pretty similar to each other. So the easiest formula is recursive, which is essentially what we do. If I told you to find the next term, you would just multiply whatever our ratio it is to the next term. So our recursive formula has our a of 1, or first term, is equal to k. And remember, k is just equal to some number. That's all k represents. It's just some number. Then we have a of n which is just meaning the nth term. So the nth term is equal to our common ratio times a of n minus 1. And all a of n minus 1 means is that it's the previous term. So whatever term came before the term we're trying to find, that's what we will use to multiply our ratio to get the next term. On the other hand, there's our explicit formula, which just states that a of n, or our nth term, is equal to a of 1, which is our first term, times our common ratio raised to the power of n minus 1. And remember, n is just the term number. So for example, if I asked you to find a of 10, that means we're finding the 10th term, so n's equal to 10. So n's equal to 10. If I asked you to find the 31st term, n would be equal to 31. All right, that's what I mean by n. Now, what does the explicit formula look like to you? Does it look familiar? How? Why does the explicit formula look familiar? Elise? It looks exactly like our exponential function. An explicit formula is pretty much exactly our general form of an exponential. It's just written differently. Because a of 1 would just be our a value, which remember, a value is our y-intercept or our initial value. R, we already said, is the same as our b value. And then the n minus 1, that could just represent our x. And then a of n is your y. So it's essentially the exact same as an exponential function or your exponential formula. Now, best times to use these two formulas. An explicit formula you can use in any circumstance. As long as you're given the first term and the common ratio, you can use it in any circumstance. The recursive formula is only useful if you know, so we use if we know the previous term. If you do not know the previous term, in some cases you can brute force it depending on how low the number is. But in other cases, it'd be way quicker to do the explicit formula. So for example, if I asked you to find the 30th term, if they did not give us the 29th term already, we should use the explicit formula. All right. But if they asked me to find the 4th term and they already gave me the first 3, recursive would be the easiest thing to use. All right. So you switching between the two formulas, when in doubt, use explicit. All right. When in doubt, use explicit. But the recursive formula can come in handy when you're just trying to find fairly low. Guys, quit. All right, so let's look at example 2. Now, it asks us to find the 4th term, but I want to find the common ratio first or the number we're multiplying. So it may not look like we're multiplying a number, but we actually are. I recommend using your calculator to figure that out. Because the number is going to be a fraction. And it's not a nice fraction. Well, I guess it's a nice fraction, but it's not one you would think of off the top of your head. So I recommend using your calculator to figuring out what my common ratio is. So what number am I multiplying to get from 16 to 12 and then from 12 to negative 9? So to get from negative 16 to 12 and to get from 12 to negative 9. So guys, I should be seeing everyone using their calculators trying to figure this out. If you don't have a calculator, grab it.
Is it not popping?
No, it's just a screen.
That just means it won't turn on. Let me see if I can use my magical touch. This is the one that's finicky, and I know I just replaced the batteries. Just saving you the trick. That's what I'm doing.
All right, did anyone get a number that we're multiplying by? I want it as a fraction. So guys, just to kind of help us out here, if we don't know, we know we're having to multiply a number to get from negative 16 to 12. But if we don't know what that number is, what's the easiest way to find that number using those two numbers? Divide what? So we're dividing. What am I dividing? 12 by... Nope. Yeah. So we're doing 12 divided by negative 16. And you'll get a number, which is what is a fraction? Negative 3/4. Now, does that also work when we divide negative 9 by 12? Do we get the same number? So if we divide negative 9 by 12, do we get the same number? Yes, we should. So we're multiplying negative 3/4 to get to each number. So the common ratio is negative 3/4. And again, if you don't know, because it may just be a weird fraction, if you don't know what you're multiplying by, like it's not obvious, do the second term divided by the first term. That'll give you negative 3/4. Then to check yourself, do the third term divided by the second term. Still gives you negative 3/4 if you simplify those two fractions down. All right, that's the easiest way to figure it out. Guys, heads off desk, you'll be sitting in the chairs with whiteboards. Now that we know we're multiplying by, figure out what the fourth term is. So multiply negative 9 by negative 3/4 and see what you get. And I want this as a fraction. Aiden, what'd you get?
I don't think this is right, but I got 6.75.
Convert that to a fraction. It's correct, but I just want it as a fraction. Hit math, enter. So Elise, what'd you get?
27 over 4.
Positive 27 over 4. Which that is the same as 6.75. Yes, that's correct. And remember, if you don't remember how to convert to a fraction in your calculator, hit the math key and then enter twice. Yes. Now, it then wants us to write the recursive formula for A of n. All right. So remember, for either of the formulas, we need two things. We need A of 1 and we need R. We have both of them already. What's a of 1 equal to? Negative 16. What's r equal to? Negative 3/4. So those are the only two values that we're going to plug and chug back into both of these two formulas. So the recursive formula, we're just going to plug in wherever a of 1 is and the r is. And then when we do the explicit formula after that, same thing. Those are the only two values that you need to plug in. Everything else you just rewrite. So with the explicit formula, remember it's two pieces. A of 1 is equal to, a of n is equal to. A of 1 is equal to what?
It's -16.
Negative 16. Now, a of n is equal to r times a of n minus 1. So you keep the a of n minus 1 where it is. That all that means is whatever the previous term is, that's what you're multiplying by. So what are we multiplying to that a of n minus 1? What's our r value equal to? Negative 3/4. So that's our recursive formula. Now our explicit. So again, still using the same a of 1 and r values, but now we're plugging it into this formula. And again, all we're doing is replacing the a of 1 and the r. So I would have a of n is equal to what? Negative 16 times what? What's the next part of the formula? Negative 3/4, all raised to the what? Nope. What does it say in the formula? N minus 1. And that's your explicit formula. So guys, coming up with these formulas are not hard, especially if you have your a of 1 and r value already figured out. All you have to do is plug and chug into the formulas. You literally just replace the values in your formulas with your a of 1 and r values. Then anything else that you're not replacing, that just goes in as it is. You just write it down as it is. Now, it then wants us to find the 9th term. Now, which formula would be the most effective to find the 9th term of this sequence? Which one, the recursive or the explicit? Explicit. Why would you think explicit, Elise? Well, let's think about it. What did I say is the best way to use the recursive formula if we have the what? So guys, if we use the recursive formula, we have to have the what? I literally wrote it up here. We have to have the what? The previous term. All right. So that means that we need to have the 8th term to find the 9th term. Do we have the 8th term? No. So that's why the explicit rule is best. Because the explicit rule, we don't need a previous term. We only need a of 1 and the common ratio and then the term number. So if we're finding the 9th term, that means n in this case is going to be equal to what? What's n equal to? So we need to plug in something for n here. What is that n equal to if we're finding the 9th term? 9. We're finding the 9th term, so n's equal to 9. So we're just going to plug in 9 for n and put it in our calculator. So I would get a of 9, because that's the 9th term, is equal to negative 16 times negative 3/4, all raised to 9 minus 1. Then we can just put all of this in our calculator to get an answer. So we're going to do this part together. So I'll do negative 16 times negative 3 divided by 4, which is 3/4, all raised to. Now we all know 9 minus 1 is 8, but just for, formula's sake, we'll just type in parenthesis 9 minus 1 and then hit enter. We get what looks like an ugly decimal. All right. But just to be sure, I'm going to hit math enter, enter, see if it turns to a fraction, which it does, but it's just an ugly fraction. All right. So for this one, I would say give me that fraction, but if not, round to the nearest tenth. So the two answers that I would accept is a of 9 is equal to negative 6561 all over 4096, or that is also approximately negative 1.6. But if you give me approximation, you need to give me the approximation symbol. All right. Do not tell me that a of 9 is equal to negative 1.6 because, given our calculator, it clearly is not. It's approximately negative 1.6. And remember, the approximation symbol is just a squiggly equal sign. All right. Any questions on how to use an explicit formula? All right. Now, example 3. They gave us a geometric sequence, but they only gave us the recursive rule. So remember, your recursive rule gives us our first term, and then how we get to the next term given the previous term. And it wants us to find b of 2, b of 3, b of 4, and b of 5. So in other words, if I rewrote this, this would be b of 1, subscript 1. So this would be b subscript 2, b subscript 3, b subscript 4, b subscript 5. They just wrote it a little bit differently. This would be b of n minus 1, b of n. So don't be fooled because sometimes you can write it a little bit differently. If they don't have the subscript, it still just means find the second, third, fourth, and fifth term. So, given that this is a recursive formula, which term do we have to find first? 2, 3, 4, or 5? 2. Why? Not necessarily. Why do I absolutely have to find the second term first? If I'm only given the recursive formula, that means I'm using the what? What's the only way you can use the recursive formula if you have the what? The previous term. Well, what's the only term that we know for a doubt? Yeah. We have B1, which is equal to 4. So we have to find B2 because the previous term of B2 is B1. So if I find B2, that'll be equal to, what would I be multiplying to the 4, which is my B1? What does it say in my formula? So right here, we're multiplying 3 to it. So that's my R value or my ratio. All right. So this would be 3 times 4, which is my B1 value, which is equal to what? 12. How do I use that to find B3?
Multiply by 3 again.
2.
Well,
Multiply 3 to 12. So that'll give you 36. And then you just keep repeating that pattern. So B4 is equal to 3 times 36, which is 108. B5 is equal to 3 times 108, which is 324. So if they give you a recursive formula and they ask you to find the next couple of values, that's just how you do it. You figure out where you're starting from or your first value, and then you figure out where your common ratio is, which in this case is 3. So not only do you have to know how to make it, guys, heads up. Not only do you have to figure out how to make it into a formula, you also got to know how to read a formula and decipher what's going on. Any questions on that one? All right, we're going to skip number 4 because it's pretty much exactly what we've been doing the past couple of weeks with tables and exponential functions. Same thing. Let's go to number 5. So number 5, we're creating a sequence from a word problem. And this may sound familiar. So Dina opens a savings account at the end of the first month. So at the end of the first month, she had $24,000 in her savings account. Each month after, she withdrew 24% of her savings. And we're going to model this scenario as a geometric sequence. Now, they already told us that S of 1, or same thing as A of 1, is equal to 24,000 because that's where we started at. Now, they also gave us the common ratio, well, kind of. So think about this logically. If we're withdrawing from our bank account, does that mean that I'm putting money in or taking money out? Taking it out. So does that mean that by the end of each month after the first, will I have less money than what I started with or more money than what I started with? Less. All right. Now, what does this problem kind of look like to you? Something that we already learned previously for this unit. What does this problem look like to you? An exponential what? Well, guys, it's got to be an exponential function. But it's a very specific type. I'll give you a hint. Lesson 6.3. What was that all about? Decay. It's an exponential decay. All right. So this is very similar to an exponential decay problem, which we know the formula is A times 1 minus R raised to the T power, where R in this case is our rate of decay. So R is not the common ratio in this case, rate of decay. So if my common ratio is my B value, which in this case is 1 minus R, so that'll give me my B value. How do you think I'll find my common ratio here? Solve what?
Do 24% divided by 100.
So first we would do 24% divided by 100 because we need it as a decimal. So that'll be 0.24. Then what do I do with that? Right, do 1 minus the 0.24. So my R value, or my common ratio, is equal to 1 minus 0.24, which that means that R would be equal to 0.76. Now, why is it that I would have to multiply 0.76 and not 0.24 to get to my next value in the sequence? Why is that? So think about this logically. If you multiply 0.24 or 24% of 24,000, would that give you the money that you took out or the money that you have left? I'm trying this back. That's the money that you took out. So if I multiplied 24,000 by 0.24, this is the amount of money that I took out of my account. I took $57.60 out of my account. But I want to know how much I have left in my account. So essentially, if 24 is 100% and I subtracted 24% from it, that means I have 76% of my cash left in my bank account. So whatever 76% of 24,000 is, or 24,000 times 0.76, that's how much money I have left in my account after the first month. So I actually have $18,240 left after I take out the $5,760. So guys, that's not just a math thing, that's just logic. All right? If you know about banking, for example, if you want to know how much money you would gain on interest, all right, you'll learn more about that in Math 3. But with interest, if you leave some money in a bank account for a while, usually the interest rate is between 1 to 5%, depending on the account type. After every month, they add a little bit of more money to your account based off the interest rate. And how they do it is they take, say, 5% of however much money is in your account and add that to your current account. Same thing if you're withdrawing. If you're withdrawing 24%, in reality, you only have about 76% of your cash left. Does that make sense? So if we're going to write a recursive rule, remember, you need your S of 1 and your R value. We already have both. So what's my S of 1 value? 24,000. Now, we still have times S of n minus 1. But then what's my common ratio that I'm multiplying to S of n minus 1? 0.76. So 0.76. So that's our recursive. Now, our explicit rule is going to be just like if we wrote out the exponential decay equation, just replacing the t with n minus 1. So what do you think my explicit rule would be? It would be S of n is equal to what? What's my first term? 24,000 times what comes next? 0.76, and it's all raised to what? N minus 1. That's all you got to do. So that problem was a bit more of a thinker, but it also applied something that we already learned in this class. All right, so that's it for notes for today. So for the rest of class, you do have a new Delta Math. All right, it's very quick.